Assalamualaikum and good day to my panelists, Dr. Muhammad Taufik bin Taib and also TS Muhammad Harizal bin Osman. My name is Rudi Aktar bin Hussain. My metric number is B091810132. Now I would like to present my Bachelor Degree Project 2 or PSM2. My topic is the effect of laser engraving parameters on the surface morphology and quality of low carbon steel. My supervisor for my PSM is Professor Madya IR Dr. Muhammad Azli bin Abu Bakar. So let's move on to the first slide, which is the introduction. The introduction is the laser engraving is a laser machining process that utilizes laser to engrave on the surface of material. Laser engrave uses concentrated beam to engrave image or text or any desired pattern on the surface of material. Next is the laser cleaning. It's a method using focus beam to rapidly vaporize or remove the contaminate or rusted layer on the surface material. Next is laser engrave is a technology that reduces human effort and time, where in traditional method of engraving it require a lot of human effort and time to engrave the material. So in 2022 we need to reduce time. It's already IR 4.0, so we need to use technology to create a more efficient and high precision product. So here is the example of traditional engrave versus laser engrave. For traditional engrave, it requires a lot of human skills and time to actually laser engrave, but the quality is unknown, depends on the human skill. And for laser engrave, it always can engrave very fast and efficient, and also high precision of result. Next is the problem statement. The first one is MOPA fiber laser is still a new technology for laser engraving. Next is the carbon steel is not commonly used in laser engraving. And the effect of laser engraving on laser clean surface of low carbon steel is still unknown. Then the temperature of the heat produced from the laser, especially higher power or lower pulse frequency, can affect the surface quality of the material. Then the changes of microstructure and surface roughness of carbon steel is to be determined by the laser parameter we need to identify. That is the research objective. The first objective for my research is to use MOPA fiber laser engrave machine to laser engrave on normal surface and laser clean surface of low carbon steel. Next objective is to identify the effect of laser engraving with different parameters on surface quality of carbon steel. The parameter used in the laser engraving is laser power, pulse frequency and laser speed. And to identify the quality of the the surface quality after laser engraving is to the surface roughness test. Next, from the surface roughness test bring us to the third objective is to observe the characteristic of structural and microstructure changes produced by the laser engraving on low carbon steel by observing microscopic images. Next is the scope of study. The first scope is to use master oscillator power amplifier MOPA fiber laser engrave machine to laser engrave on normal and laser clean surface of the low carbon steel. Next is to use different laser parameters such as laser power, pulse frequency to find the best quality of laser engravement to surface roughness. In this experiment research, I only uses the same laser speed, which is 1000 mm per second, to set it as a constant for every engraved boxes. Then next one is to study the microscopic structure of low carbon steel after laser engraving using Nikon Eclipse LV 400 microscope. The next part of the presentation is the literature review. It is the timeline of the laser from as you can see from the slide. In 1916, Albert Einstein discovered the first principle of laser, which continued in 1928. Rudolf Landenberg discovered an accidental evidence of energized emission. Then later on in 1940, Valentine A. Fabricant found that stimulated emission can generate laser. Next in 1951, Charles Hussain developed laser, and later on in 1960, Theodore Maiman developed the first UV laser, and later next The rest is history. Until now. The next literature review is MOPA fiber laser is basically a more upgraded version of conventional fiber laser engraver machine. The advantage of the MOPA fiber laser, the pulse shape can be tuned arbitrarily by changing the driving current waveform for the seed diode. MOPA fiber laser utilizes the master oscillator to produce laser beam, while the output power is produced from the optical amplifier. The master oscillator, which can handle much higher frequency and give shorter pulse than others, produces the beam, while the other optical amplifier is used for boosting the output power. The next part is the methodology. As you can see, is the flowchart for my PSM. The flowchart combine PSM 1 and 2 together. Okay, here is the most important aspect in the experiment, which is the software and equipment needed for the experiment process. The first step is designing. To design using Adobe Illustrator, because using Adobe Illustrator, the file can be saved as vector image. So it is important to save as vector image for the laser engraving software to easily detect the structure of the pattern. Then I design square boxes. To each square boxes represent different laser parameter. Next is the process, which is the laser engraving process. The laser engraving is using MOPA fiber laser engraving machine with different laser parameter, which I will show on the next slide. Then the next one, lastly, is the analysis. The analysis is made with surface roughness test and microscopic observation. Here is the laser parameter for the experiment. The first one is laser cleaning parameter. Laser cleaning parameter is only used on the second sample. The laser engraving parameters is used on the both sample. So the first sample is only on normal or original surface. The second sample utilizes laser cleaning method. So after laser cleaning method on sample 2, it uses the same laser engraving parameter as sample 1 to laser engrave on the carbon steel. Here is the video of the laser engraving and laser cleaning process for my experiment. Okay, here is the result of the laser engraving. For sample 1, as you can see, the surface is quite the surrounding surface is quite dark because it is the original surface of the carbon steel. Then on the next is the sample 2, is the laser clean surface. As you can see, there are a lot of different in colors of the engraved boxes between the two samples. So it is important to identify the surface roughness of the each engraved boxes between the two samples. So let's move on to the next slide, which is the result and discussion. For result and discussion, the samples were tested with surface roughness test to identify the surface roughness value. So the surface roughness value were taken 3 times, and the average of the surface roughness value was calculated. And from the surface roughness value, it is tabulated into graph to give a better understanding on the surface roughness value on different laser power and pulse frequency. So as you can see, for sample 1, the surface roughness value increase gradually from 20% until 80% laser power. Then at 80% laser power, every pulse frequency start to have some have higher and some has lower surface roughness value at 100% laser power. For sample 2, the result is quite different with it's very different with sample 1, which the first laser power is the lowest laser power. It got the highest surface roughness value for sample 2 for every pulse frequency. Then it dropped at 40%. Then later on it increased again until 80%, and later on drop at 100% laser power. So the table below shows the minimum roughness and maximum roughness value of sample 1 and sample 2. As you can see the value, and from the surface roughness value, it can be determined that for sample 1, lower power laser power give the best result for, or lowest surface roughness reading for all the pulse frequency. While for sample 2, the laser power, 40% laser power provide the best result of laser engraving on the surface quality, which at the 40% laser power it shows the lowest reading for surface roughness value for all the pulse frequency. For the while the maximum roughness it basically is not the best quality, it's the lowest quality, where the high surface roughness is caused by the surface deformation and oxidation for sample 1. Due is because laser power is the main factor for sample 1. As you can see, at 100% laser power and 80% laser power, the surface roughness value is very high. However, for sample 2, the lowest laser power shows the highest surface roughness reading, because the lower laser power, it doesn't have enough energy to penetrate the surface layer of the laser clean surface. Next, move on to the microscopic image. Here is the microscopic image for 20% laser power category, which I put minimum and maximum surface roughness value and illustrate the microscopic image. The microscopic image is taken with 3 type of magnification, which is 5 times, 20 times, and 10 times. So it got 3 data for each sample. So as you can see, the most visible roughness visible to us is on the maximum surface roughness value, where you can see the structure of the engraving is very rough and uneven on the sample 2, while on sample 1 it shows a very more even and parallel line of laser engraving on the surface. So I would like to conclude my PSM with conclusion and recommendation. So for conclusion, it shows that different laser parameters such as laser power and pulse frequency will lead to different result, because especially with different type of surface, it also will bring different result from the laser engraving. As you can see just now, for sample 1 and sample 2, the laser power provided different surface roughness value for both sample, or because both sample is from different type of surface. Then here is the recommendation for future study, is to conduct more analysis tests. Example is hardness test, and to laser engrave on different type of carbon steel materials such as medium or high carbon steel, and to use different laser speed, because I use constant laser speed, which is 1000. In future, maybe can use different laser speed from 500 maybe until 4000 laser speed. So that's all for my PSM2 presentation. I would like to thank you for to my supervisor, my friends and my family, and also thank you for panels for watching my video. And that's all. Thank you so much. Assalamualaikum.